Hi, my name is Bola. Today we're going to talk about networking in Android, transferring your static apps that always shows the same information whenever you launch it to a dynamic lively app.
Imagine launching Twitter 100 times a day, and each time you see the same tweets. They are hard-coded into your app, and you simply have to wait for the company's next release to be able to see new stories. Inconvenient, right? Let's first agree that any useful online platform consists of two parts. The front end of the service, which appears to the user via mobile phones or web pages, and the back end of the service, which acts like an engine. It does all the hard work, like storing tweets and showing the proper news feed. Server helps us do so with the help of the API to send data to the front-end devices. I'll compose a path for you guys so we can be all on the same page. Here's what we are going to discuss in this tutorial. We currently have a bundle of data on a server, and we need to retrieve it to our phones. This will be possible with the help of APIs. APIs provide a simple way and a fast way to communicate between servers, which acts like a backend, and front-end devices. Think of it as rules that programmers do to control what to send and to whom and when. Having all the data in our server, we need a way to pass them to devices. This is where JSON comes in handy. JSON provides a simple way to send data as a text over the web, just by making a simple HTTP request via an app or your PC's browser. More on that later. Let's dive in JSON and see its components. Here is a simple JSON response, consisting of some text, bunch of columns, commas, and quotation marks. The left side of the column is called a key. They are used to access values on the right-hand side. Therefore, to access the string value Mike, you need to access the key name. Same applies to country, birth year, and hobbies. Values can be anything from strings, numbers, arrays, and objects. By looking to our example, we can find that we have string values such as Mike and Egypt, number values such as 1997, and also object values such as the highlighted part corresponding to hobbies. You can easily interpret this highlighted part as another JSON formatted text inside the main JSON file. It consists of keys such as coding and others, which have a string value of Photoshop design. I think it's now easy to find out that the key coding has the value of type array, containing a bunch of inner strings. Now, we need a way to receive the JSON text file. We do so by storing a specific URL in the application's code. Next, we make a request with that URL, and then simply wait for the server's response. Before entering through too many details, let's see what happens under the hood. As you can see, if you requested the JSON file via your own browser, you'll receive the plain text there. Later on, we'll be making those requests within our app. Let's dive into some details about how this specific URL is chosen. This URL consists of several parts. We are just going to focus on the main parts. First up, the base URL. This is the consistent part of the URL. This should not be changed if you are opting for different datasets from the same server. Basically, that is the part responsible for locating the needed server. But what if I wanted to receive another set of data? APIs has different endpoints and can show different results depending on the query. So for example, here I wanted a list of my friends that has a length of just 1. I can also request a list of my family members containing 125 persons, whatever I really want. Different ways of querying a specific site's API can be found on the documentation. Be sure to check those before starting your project. They are really helpful and always come in handy. Okay, great. We've done a great job until now. We figured out what are APIs, JSON responses, and how to retrieve them through a URL request. Now we're going to try to implement those concepts into our app and make it a bit more useful. I have coded a simple weather app that should consume the Open Weather API. However, for now, it just shows this screen every time I launch it. Let's fix that. We will need a URL that requests a JSON file, so we can parse it and extract the info we need. I've got myself a nice URL from their documentation site. Let's break into parts to make sure we are right on track. This is the URL we'll be using. The base URL is highlighted on the slides. We will then add some parameters to flavor our response based on our needs. We need to know the weather in Cairo. We need it to be in metric system. I don't want Fahrenheit in my app. Moreover, the server should know whom he's talking to. So we need to add our user ID. This should be unique for everyone. Now, on to coding. Let's see how we could achieve this custom URL through code. We will be using the URI class and its builder. I will begin by specifying the base URL. Start building and add parameters to it. The return value should be exactly what we need. Moreover, here is what the response should look like when I make the request through that URL in my browser. I will just choose the info I need and leave the rest. So I'll pick weather key and main key and name key. Remember, those are all in the root response. Let's parse the key weather. Obviously, the key weather has a value of an array of one element. And that element is indeed a JSON object. We will need to parse that too. To get the value of sand, we will need the key description. Easy, right? Next up, we'll parse the key main. This will be easier. We just need the value of the key temp. Notice the following. Unlike the key weather that had a value of an array, the key main doesn't. Also notice that the value of the key main is of type object. Finally, the key name has the city name Cairo. No need to do a lot of parsing. The key is just chilling in the root of the JSON response. Let's jump onto code and see how all the parsing we just did will be implemented. We will be creating the variables first, so we can initialize them and use them later. Notably, we use two nested try and catch blocks. The inner one is used to catch errors that would happen while trying to connect to the internet. Those errors could be thrown by the make HTTP request function. We will not talk about this function for now, but just so we can be all on the same page, this function uses an input parameter as a URL and returns a plain JSON response as a string, much like a browser did a few slides back. The next try and catch block catches error in the parsing of the JSON itself. Now comes the part of the actual parsing. First, we will convert the plain string containing the JSON response to a JSON object. We will then use the object we just created to find the array value corresponding to the key weather. Then, we will get the one and only element of that array and cast it to a JSON object as well. Finally, we will find the value corresponding to the key description within the weather object. By the same procedure, we will get the value of the temperature, then the value of the city name Cairo. Finally, we will create a new weather object that has all the data needed to inflate views within the app. Then return that object. Okay, we're almost done. We just need to plug in this function into our main activity, retrieve the weather object, and extract the weather details to the layout. Right? Not quite. Turns out we shouldn't network on the main thread. Imagine a slow internet connection. This will result in freezing the app till the connection is closed. Android simply doesn't like that. To solve this issue, we will use something called loaders. We will just make the main activity implement the loader manager callbacks. This means that we will have to implement the needed functions too. We will just focus on implementing the onCreateLoader function, where all the networking should happen. Notice that the onCreateLoader function needs to return a loader object. Let's figure out how to do that. I created a simple class, WeatherLoader, that extends the async task loader class. Constructing this class needs a string containing the URL and the context. As soon as we construct this class, it will call the extractWeather function, which needs to connect to the internet. This is the one causing all the pain. So, we are calling these functions within the load in background, causing the whole process to run in another thread, avoiding the blockage of the main thread. Now let's return to our main activity and plug in our newly created class. Now we need to inflate our layout and its inner views when the loading finishes. The inflate element function just needs a weather object, and it will do all the hard work of retrieving data from that object through simple getters, and would then set text views and valid information. Good job for sticking all the way. One checkbox is still to be ticked. We have to let Android know that our app needs access to the internet. Adding this line in the manifest file should do the work. Congratulations! You just finished the video and made yourself an Android weather app. Go ahead and try implementing those new concepts in your code. I will be leaving all the project file for reference, but I would recommend to try on your own first. Thanks for watching. Bye.